the vast silence of space, light is the only messenger. Every photon carries a memory, a faint echo of where it has been and how long it has traveled. Some of these whispers are newborn, cast off by stars that burn bright today. Others are ancient, so old that their journey began before Earth was even formed, before the sun had even lit its fire. The James Webb Space Telescope was built to catch these fragile ghosts, to hold their voices in its golden mirrors, and to let humanity hear the first syllables of creation itself. But within its first gaze, something appeared that should not be there. Galaxies, vast and luminous, shimmering with billions of stars, standing defiantly in an era where the universe should have been too young, too chaotic, too unformed to allow them. Structures that theories said could not yet exist had already risen. In the darkness, carved into the early fabric of space-time, for decades, the story of the cosmos had seemed clear, a beginning in fire, followed by a long, patient unfolding. Yet what Webb revealed suggests another tale, one where time itself seems to run too fast, where the infant universe wore the face of maturity long before it should have. If time is a river, then Webb may have glimpsed eddies that turn against the current, places where history folds back upon itself. The telescope was meant to show us where we came from. Instead, it has revealed something that breaks the rhythm of our cosmic story, something vast, impossible, and undeniable. The universe, it seems, is hiding something it should not possess. The story of this mystery does not begin with Webb, but with its predecessor, a sentinel named Hubble, launched into orbit in 1990. The Hubble Space Telescope became humanity's first great eye beyond the blur of our atmosphere. With it, astronomers opened windows into the distant past, capturing images of galaxies whose light had been traveling for billions of years. When Hubble revealed the deep field, a seemingly empty patch of sky transformed into a sea of thousands of galaxies, it was as if the universe whispered that infinity lies in every dark corner. Yet, even then, the puzzle pieces did not always fit. Some galaxies appeared surprisingly mature, luminous, and structured, given their apparent age. The evidence was subtle, almost fragile, and many cautioned against over-interpretation. But the questions lingered. Could the universe have built its great structures faster than theory allowed? This was the promise entrusted to the James Webb Space Telescope. Conceived as Hubble's successor, Webb was designed not merely to look farther, but to see deeper into time itself. To glimpse the cosmic dawn, where the first stars flickered into existence, and the earliest galaxies took form from hydrogen and helium, the raw breath of the Big Bang. To do this, engineers crafted an instrument unlike any before, a mirror of gold segmented into perfect hexagons, stretching 6.5 meters across, a sunshield the size of a tennis court, unfolding with the precision of origami, instruments cooled to temperatures near absolute zero, allowing Webb to detect the faintest infrared whispers, the stretched-out light of the most ancient stars. Cosmology had set clear expectations. According to the timeline, the universe's first 100 million years were a dark age, a silent sea before the first sparks of starlight. Galaxies, it was thought, would appear gradually, faint and chaotic, fragile clouds of stars in the making. The deep fields of Webb were expected to show these beginnings, simple and primitive, aligned with theory. But when its golden eye opened, the silence was broken. In its very first images, galaxies emerged, not dim and formless, but brilliant, massive and complex, appearing when the universe was only a fraction of its current age. They were too bright, too vast, too soon. It was as though Webb had torn away the veil of expectation and revealed a cosmos that had grown up before its time. A universe in defiance of its own history, hiding galaxies that, by every known measure, should not have been there at all. First images from Webb were greeted with awe. Glowing webs of galaxies scattered across the void. Arcs of light bent by gravity, stars pricking through the dark like shards of fire. Yet buried within the beauty was something far more unsettling. The galaxies appearing in those fields were not the fragile, infant structures theory had prepared scientists to expect. They were mature, luminous, and enormous, formed in what should have been the age of cosmic infancy. The reactions came swiftly, carrying a strange blend of exhilaration and unease. Astronomers who had waited decades for Webb's vision now found themselves confronted by results they could scarcely believe. Some spoke of sleepless nights, of numbers checked and rechecked, as if the data itself might yield a mistake. Others admitted to a sense of vertigo, the disorienting recognition that a cornerstone of cosmology may have cracked beneath them for over a century. The Big Bang model had given order to the cosmos. It traced the story from a hot, dense beginning to the slow emergence of galaxies, stars, and planets. The timing was supposed to be certain. Galaxies could not exist in great numbers within the first few 100 million years. Yet Webb's findings seemed to place massive galactic systems almost at the dawn itself. Caution ruled the first public statements. Scientists reminded the world that extraordinary claims require extraordinary evidence, that these results might be explained by errors in estimating mass or distance. Perhaps the galaxies were smaller than they appeared, or perhaps their light was deceiving us through cosmic dust. But even in their careful words, one could hear the quiet tremor of possibility that something far more profound was at stake. For some, it recalled earlier moments of upheaval, when Copernicus displaced Earth from the center of the cosmos, when Einstein bent space and time with relativity, when Hubble revealed that our galaxy was not alone but one among countless others. Each time, humanity's vision of reality had shifted, forcing old certainties to fall away. Now, with Webb's golden mirrors fixed on the past, it seemed another shift might be approaching. Still, one haunting question lingered in the minds of all who looked at those images. If these galaxies truly existed so early, then what did we misunderstand about the birth of everything? The arrival of Webb's first deep field images rippled through the scientific world like a tremor. Within hours, astronomers across the globe were poring over the data, tracing the faint signatures of galaxies scattered across the tapestry of ancient light. The images were breathtaking, yet it was not beauty alone that stirred them. Hidden within the deep crimson glow of distant galaxies lay a contradiction forms that should not have existed so early, shining with the mass and order of systems that should have taken billions of years to mature. The first reactions were a mixture of awe and disbelief. Teams who had spent decades preparing for this telescope's gaze suddenly found themselves confronting results that defied the framework they had worked within their entire careers. Whispered conversations filled observatories and research centers. Could the data be wrong? Could their instruments be deceiving them? Some spoke of sleepless nights, haunted not by the faint galaxies themselves, but by the implications they carried. Caution was everywhere. Scientists reminded the public and themselves that first impressions could mislead. Perhaps the galaxies were smaller than they appeared. Perhaps the distances had been overestimated, or perhaps dust was bending the colors of their light. Errors, after all, were familiar companions in science, and yet, even amid the doubt, the unease deepened. Each recalculation, each reanalysis, brought the same conclusion back into view. These galaxies were real, and they were far too massive, far too luminous, far too early. The press seized upon the discovery. Headlines proclaimed, "Galaxies older than they should be." The question mark hovered like a warning, as though even journalists sensed that something fundamental might be at stake. For the wider public, the notion was staggering, the possibility that the very timeline of the universe might need rewriting. For scientists, the weight was heavier still. Careers had been built upon the Big Bang model and the slow, orderly unfolding of cosmic history. If Webb was right, the foundations of that story were shifting beneath their feet. Many felt the echo of past revolutions. When Copernicus dared to move Earth from the center of creation, when Galileo raised his telescope and revealed moons circling Jupiter, defying centuries of dogma, when Einstein reshaped space and time into a fabric that could bend and stretch. Each of those moments had carried both wonder and disquiet, for they had shown that reality was stranger and more unsettling than humanity had dared to imagine. Now Webb's findings seem to whisper a similar message, that the universe may not be telling the story. We thought we understood, and so the question lingered, unspoken yet undeniable. Are we wrong about the timeline of everything? For many, the discovery carried an almost existential weight. In hushed tones, scientists admitted to feeling as though the cosmos itself had tricked them, as though a curtain had been pulled back to reveal a stage that should not yet have been built. One astronomer described it as the floor falling out from beneath our theories. Another confessed that the images filled them with both exhilaration and dread, for they hinted not just at answers, but at questions far more profound. Behind closed doors, debates grew fierce. Some clung tightly to the standard model of cosmology, insisting the anomalies must be illusions born of data still too raw to trust. Others began to consider what few dared to say aloud, that the universe might not be following the script written for it by equations and simulations. If galaxies could rise so early, then perhaps the very laws guiding the growth of structure were different than assumed. Perhaps the forces of dark matter and gravity had acted more swiftly, or more mysteriously, than current theories allow. The emotional toll was not hidden. Accounts emerged of scientists unable to sleep, lying awake with calculations echoing in their minds, haunted by the thought that decades of careful work might have been built upon a partial truth. Yet alongside the unease was something harder to define, a spark of wonder, the recognition that to live in such a moment is a rare privilege. Few generations are confronted with evidence so powerful that it forces the rewriting of the cosmic story, and always the echoes of history seemed close at hand. Einstein, confronted by the idea of an expanding universe, had once called it repugnant, only to see it confirmed by Hubble's discovery of distant galaxies rushing away. Hawking, gazing into the paradoxes of black holes, had admitted that nature often resists the boundaries imposed by human expectation. Each generation of scientists had faced moments where reality defied their understanding, and each had been changed by it. Now, in the wake of Webb's revelations, the scientific community stood again on that familiar threshold, a place where knowledge ends and mystery begins. Some stepped cautiously, unwilling to abandon the security of long-held models. Others stepped boldly, willing to let go of certainty and stare into the abyss of the unknown. Yet whether cautious or bold, all shared the same unsettling realization that the universe was not yielding its secrets easily. The galaxy's web revealed were not just distant lights. They were riddles, questions written in starlight, challenges to the very rhythm of cosmic time. The astonishment of those first reactions was not a fleeting spark. It lingered, it spread, it deepened, until it became clear that the mystery Webb had uncovered was not an error, not a misstep of observation, but a truth that demanded to be faced. And as the data poured in, it became impossible to deny. The early universe was not what science had imagined. The question remained, as sharp and unavoidable as ever. If these galaxies truly existed so soon, what else does the universe hold that should not be there? The first reactions gave way to scrutiny. Wonder and unease were not enough. The data had to be tested, broken apart, and verified. Webb's golden eye had revealed galaxies that seemed impossibly ancient, but appearances could deceive. The key to truth lay not in images, but in the spectral fingerprints of light itself. Spectroscopy became the decisive tool. By dispersing a galaxy's light into its elemental colors, astronomers could measure the degree to which it had been stretched by the expansion of the universe, its redshift. Each redshift was a time stamp, a record of how far back in cosmic history that light had begun its journey. What the spectra revealed was sobering. The galaxies were not their redshifts placed them in the earliest epochs, only 200 to 300 million years after the Big Bang. They were real, and they were old, older in some sense than theory allowed them to be. The scale of the problem came into sharper focus. These galaxies were not faint smudges of starlight, the fragile beginnings of structure. They were massive, some rivaling the Milky Way in size, filled with billions of stars, already enriched with heavy elements that required generations of stellar death to forge. According to established models, there had not been enough time for such growth. Star formation should have been slow, gradual, hampered by the cold, neutral gas of the young universe. And yet Webb's observations painted a picture of furious activity. Stars igniting in rapid succession, galaxies assembling with impossible haste. Astronomers began recalculating the timeline. If these galaxies existed so soon after the Big Bang, then either the universe had evolved at a breathtaking pace, or the models guiding cosmic history were missing a fundamental truth. Simulations were rerun, parameters adjusted, assumptions questioned. Each attempt to stretch the theories to fit the observations revealed the same rift. The universe had written its story faster than human equations allowed. Dark matter became a focal point of debate. In the standard model, this invisible substance, outweighing normal matter 5-1, provided the gravitational scaffolding upon which galaxies could form. But had dark matter acted more aggressively in the beginning? Had its unseen hand pulled stars and gas together with a speed far beyond expectation? Or was there something even stranger at play, a flaw in how gravity itself behaves across the deep fabric of space-time? The mystery thickened with every confirmation. Webb was not uncovering a single anomaly, but a pattern, a chorus of ancient galaxies, each carrying the same impossible signature. The universe seemed to resist the explanations offered to it, like a puzzle box that refused to open no matter how the pieces were rearranged. In the quiet of observatories and research centers, the realization settled in. These were not errors to be explained away. They were messages from the past, written in starlight, demanding that humanity reconsider what it thought it knew about the first chapters of creation. The question was no longer whether these galaxies existed. The question was why the universe had chosen to grow them so quickly, and what hidden laws had guided their birth in the darkness of time. Among the earliest confirmations was a galaxy, known as GLAS SC13. Its light, faint yet resolute, carried the unmistakable imprint of redshifted hydrogen, marking it as one of the oldest systems ever seen. Another, labeled CEERS 93316, soon joined the list, pushing the limits of observation to realms no telescope had ever touched before. Each discovery tightened the knot of paradox. These were not wisps of gas struggling toward cohesion. They were vast, structured assemblies of stars, already evolved when the cosmos should have barely awakened. The redshift measurements left little room for denial. Each spectrum told the same story, that the starlight had been stretched across more than 13 billion years of expansion. Arriving now as fragile threads of infrared whisper, Webb had captured not illusions, but truths, preserved across almost the entirety of cosmic history. The implications cascaded through astrophysics. Models of star formation, long thought secure, now seemed fragile. The expected pace of stellar birth, slow, hindered by the cooling and collapse of primordial. Hydrogen clouds could not account for the brilliance of these galaxies. To shine with such intensity, their stars must have formed in a frenzy, hundreds of times faster than current theories allowed. This raised a haunting question. What forces had kindled the early universe with such urgency? Some argued that dark matter had acted as the accelerant, its invisible gravity pulling gas into dense knots where stars could ignite. Almost immediately after the Big Bang, others wondered if the laws of physics themselves behaved differently. In those first instants, if gravity, pressure, and radiation had woven together in a way still hidden from human understanding. As new candidates emerged, the scale of the enigma grew. It was not a single galaxy out of place, not a lone outlier to be dismissed. It was a population, a pattern, an entire era of impossibly mature galaxies. Webb was uncovering a universe that seemed impatient, racing ahead of schedule, defying the cosmic clock that science had trusted for generations. The effect on the scientific community was profound. Papers began to flood preprint servers, each offering new interpretations, new models, new attempts to reconcile theory with observation. Some proposed exotic forms of dark energy, others revised the efficiency of star formation, while a few dared to suggest that the timeline of the Big Bang itself might require rethinking. Yet for every explanation, another paradox seemed to arise, as if the universe were deliberately guarding its secret, and beneath the calculations and the theories, a deeper reflection lingered. The cosmos appeared less like a machine that could be measured and predicted, and more like a living riddle, resisting closure, offering glimpses of truth only to withdraw them again. Webb had opened the box of creation, and instead of clarity, it had revealed a labyrinth. For the first time in decades, cosmology stood on uncertain ground. The galaxies of the early universe were no longer distant curiosities. They were provocations, reminders that reality often escapes the boundaries drawn for it by human thought. In their light lay both wonder and defiance, an invitation to rethink the story of everything, and a warning that the answers may not come easily. When Webb's instruments turned their gaze deeper still, the revelations grew stranger. Within the light of these ancient galaxies lay fingerprints, the subtle spectral lines of carbon, oxygen, and neon. These were not the raw elements born in the crucible of the Big Bang, hydrogen and helium, but the byproducts of fusion, the ashes of stars that had already lived, burned, and perished. Their presence implied that entire generations of stellar life and death had unfolded in a cosmic instant, long before theory allowed dot in the standard timeline. Heavy elements require patience, hundreds of millions of years for the first stars to ignite, explode, and seed their surroundings. Yet Webb was finding galaxies enriched with metals almost at the dawn of time itself. It was as though the universe had accelerated its alchemy, writing chapters of chemical evolution at a speed that mocked human equations. And there was more. Some of these galaxies were not shapeless smudges of infant light, but already bore spirals, disks, and structures that should have taken billions of years to sculpt. Webb revealed delicate arms unfurling like cosmic seashells, vast systems with ordered patterns where only primordial chaos was expected. Each image was a contradiction made visible, a universe that appeared too mature for its age, through the natural magnifying glass of gravitational lensing, where the gravity of closer clusters bent and magnified the light of the background cosmos. Webb glimpsed even fainter, more ancient systems. These were galaxies seen as they existed barely 200 million years after the Big Bang, flickering at the very threshold of creation. Their photons, stretched by eons of expansion, arrived at Webb's mirrors as fragile echoes of the first dawn. To many scientists, these observations carried an almost poetic weight. This was not merely astronomy. It was a form of time travel, a direct encounter with the first light of creation. Yet that poetry was inseparable from unease. If carbon and oxygen already flowed through those early stars, if galaxies already bore spiral arms, if so many structures existed so soon, then something in the narrative of the cosmos was amiss. The standard cosmological model, the one that traced the universe from a singular beginning through inflation, dark matter, scaffolding, and steady growth, was beginning to show fractures. The galaxies Webb revealed seemed to whisper, it shouldn't exist, yet it does. In that paradox lay both wonder and dread. For if the timeline of cosmic history is wrong, then every calculation built upon it, the rate of expansion, the age of the first stars, the destiny of the universe itself, may need to be rewritten. And so each image from Webb was more than a window into the past. It was a challenge, a riddle etched in light, daring humanity to look deeper and admit how much remains unknown. The presence of heavy elements in Webb's spectra was not merely a technical detail. It was a revelation that struck at the heart of cosmic chronology. Carbon, oxygen, nitrogen, these are the atoms that shape the chemistry of life, forged in the cores of massive stars and scattered through space by supernova. Their existence, so early, implied that stellar birth and death must have unfolded at a furious pace, collapsing entire epochs of cosmic history into an impossibly narrow window. To reconcile this, some astronomers suggested that the first stars, the so-called population 3 stars, might have burned with extraordinary mass and brilliance, living brief but furious lives before seeding the cosmos with their ashes. Yet even this speculation strained under the weight of observation. The galaxies Webb revealed did not merely contain the traces of a single stellar generation. They bore the marks of multiple cycles of enrichment, evidence of maturity where there should have been only infancy. The architecture of these galaxies was equally unsettling. Cosmological models had long predicted that the earliest galaxies would appear as irregular clumps, chaotic gatherings of matter slowly assembling under gravity's pull. Instead, Webb found systems with spiral arms unfurling in elegant symmetry, disks of stars in delicate rotation, and signs of ordered structure that should have taken billions of years to emerge. It was as if the universe, in its earliest chapters, had skipped ahead in the script, writing scenes of complexity long before the stage was set. For theorists who spent decades refining models of cosmic structure formation, these images felt like the ground shifting beneath their feet. The telescope's ability to harness gravitational lensing only deepened the mystery. When the light of galaxies billions of light years away passed through massive clusters in the foreground, their paths bent, magnifying their appearance like a celestial lens. Webb exploited this natural trick of Einstein's relativity to glimpse galaxies, so faint they would otherwise remain invisible. What emerged from these lenses were objects glowing at the very threshold of cosmic dawn. Galaxies seen as they existed less than 200 million years after the Big Bang. They were not tentative wisps of matter, but luminous, robust structures, each one an impossible survivor of time. Their photons had traveled across nearly the entire history of the universe, stretched into the infrared spectrum by cosmic expansion. Before striking the golden mirrors of Webb, to hold such light in human instruments was to grasp a message, written at the universe's beginning, a message that defied translation. Scientists, faced with this cascade of contradictions, could only oscillate between awe and unease. The telescope had delivered on its promise to see deeper into time than any instrument before it. But in doing so, it had exposed fractures in the cosmological model that had guided physics for nearly a century. The CDM model, the elegant framework that combined dark matter, dark energy, and the Big Bang, had explained cosmic microwave background radiation, large-scale structure, and the accelerating expansion of the universe. Yet here, in Webb's earliest images, were galaxies that seemed to grow too quickly, stars that seemed to die too soon, and elements that appeared before the universe had the time to create them. The dissonance was unmistakable. Either the observations were misleading, perhaps artifacts of calibration or interpretation, or the very timeline of cosmic history required rewriting. For many astronomers, the implications were as profound as they were unsettling. If galaxies could exist in such abundance and complexity so soon, then the scaffolding of dark matter, thought to guide the assembly of cosmic structure, might behave differently than imagined. Perhaps dark matter condensed more rapidly, pulling baryonic matter into galaxies at accelerated rates. Or perhaps physics itself, in its deepest equations, harbored gaps yet undiscovered. Some dared to whisper about new physics beyond the standard model of cosmology, forces or phenomena not yet written into human understanding. And beyond the technical debates, there lingered a sense of profound philosophical weight. The sight of these early galaxies was not just data. It was a reminder of the universe as a puzzle box, carefully locked, resisting each attempt to open it. Webb had not provided a solution, but another layer of enigma. To look at those spirals and enriched stars at the dawn of time was to confront the possibility that human beings, despite centuries of study, still stand at the threshold of cosmic truth. The universe, vast and indifferent, seemed to whisper that its story is stranger, deeper, and perhaps more unknowable than the fragile frameworks constructed on Earth. The first anomalies were unsettling, but they might have been dismissed as statistical outliers, rare cosmic coincidences magnified by the sensitivity of Webb's gaze. Yet, as the telescope's golden eyes continued their survey, the strangeness multiplied. One galaxy became many. Dozens of luminous, massive systems appeared where only dim, fragile sparks were expected. Each new observation reinforced the same impossible truth. The early universe was not a quiet nursery, but a thriving city of stars, forged and organized with impossible haste. What had seemed an isolated puzzle began to resemble a pattern that undermined the foundations of modern cosmology. The implications rippled outward into one of the most sacred chapters of cosmic theory, inflation. For decades, scientists believed that in the earliest fractions of a second, the universe had expanded faster than light, smoothing irregularities and setting the stage for all that followed. Inflation explained why the cosmos looked uniform across vast distances, why galaxies could arise from faint ripples imprinted on the cosmic microwave background. Yet if Webb's galaxies existed so soon, perhaps inflation did not unfold as gently as imagined. Perhaps it produced deeper fluctuations, denser regions where matter collapsed more quickly, creating stellar forges ahead of schedule. Or, perhaps, inflation itself was only an approximation, a shadow cast by physics still hidden, a veil over a truth more complex than equations allow. The problem sharpened further when scientists confronted the question of time itself. The ignition of stars was thought to follow a predictable rhythm, requiring hundreds of millions of years for hydrogen clouds to collapse, ignite, and enrich the cosmos with heavier elements. But Webb revealed signatures of ancient starlight. Within just 200 million years of the Big Bang, it was as though time itself had been compressed, as if the early cosmos had lived several lifetimes in the span of one. Could the laws of physics, constant and immutable in human understanding, have danced to a different tempo in the universe's youth? Or was the timeline humanity had so carefully built an illusion drawn upon shifting sands? Dark energy, too, cast its shadow over these discoveries. The cosmological constant, Einstein's reluctant term for the force accelerating the expansion of the universe, had long been a cornerstone of the CDM model. Yet Webb's galaxies suggested that expansion and structure were not aligned as theory demanded. If the universe grew too quickly, galaxies should have formed more slowly. If galaxies appeared too soon, perhaps expansion itself did not obey the rules cosmologists had assigned. Was the cosmological constant truly constant? Or was it a symbol of human hubris, a placeholder for something far stranger, something dynamic and evolving that defies comprehension? Even more startling were hints of vast cosmic structures glimpsed in Webb's deep fields, alignments of galaxies, filaments of matter stretching across distances that should not have existed in so young a universe. These immense webs, more intricate than the most delicate threads of a spider's silk, suggested that cosmic architecture was laid down with unnerving speed. Standard cosmology predicted that such grand designs required billions of years to emerge, shaped slowly by the pull of gravity and the invisible hand of dark matter. Yet here they were, emerging not in the late chapters of creation, but close to its opening lines. The universe was building itself too quickly, as though it refused to wait for the timeline humanity had assigned to many astronomers. The experience carried a weight that transcended data and calculation. In the silent glow of Webb's images, there was the sense of humanity staring into a mirror where time itself bent, where the universe revealed not clarity but paradox. Each galaxy was both a beacon and a riddle, a message from an epoch where the rules of reality seemed to blur. Were these anomalies the product of errors yet to be uncovered, artifacts of instruments, misinterpretations of redshifts, or were they the first cracks in a framework that had once seemed unshakable? In those moments of reflection, science became inseparable from philosophy. The galaxy's web revealed were not only ancient systems of stars, but also reminders of human limitation. They were symbols of a cosmos that resists being solved, that grows more enigmatic the deeper it is observed. The mystery was no longer a matter of isolated galaxies or disputed measurements. It was a challenge to the very story of creation, a whisper from the depths of time that the universe still guards its secrets, waiting for minds willing to question everything once thought secure. Under the careful scrutiny of Webb's instruments, individual galaxies began to stand out as case studies in cosmic defiance. One such object, catalogued as Jades G SC1320, revealed its light to have traveled for 13.4 billion years, a whisper from a time when the universe was scarcely 3 million years old. Its redshift, painstakingly confirmed through spectroscopy, placed it among the most ancient galaxies ever observed. But the surprise was not simply its age, it was its substance. This galaxy, so close to the dawn of time, was already host to clusters of stars, perhaps even multiple generations of them, an orchestra that should not yet have learned its song. The timelines of stellar evolution, long thought reliable, suddenly seemed fragile, vulnerable to correction. Then came CEERS 93316, another enigma lurking in Webb's deep fields. Initially, its redshift suggested a staggering age of just 235 million years after the Big Bang, far earlier than the standard model permitted for such a massive system, though later refinements would adjust its distance. The very possibility that such objects could exist spoke to the fragility of cosmological certainty. Even when margins of error narrowed, the story they whispered remained the same. Galaxies were forming faster, heavier, and more complex than theory allowed. Each recalibrated measurement only deepened the central unease. The implications spread like cracks through the edifice of modern cosmology. If galaxies were already so massive, then star formation must have occurred with astonishing efficiency. Vast clouds of hydrogen must have collapsed almost instantly, igniting into the nuclear furnaces that build the periodic table. Supernova must have erupted within a blink of cosmic time, scattering carbon, oxygen, and iron into the void, seeding the raw ingredients of life before Earth's dust was even conceived. But this raised a deeper paradox. How could such cycles of birth and death have unfolded in so little time? Were the laws of physics, as observed in the present, faithful guides to the past? Or did the infant universe operate under conditions where familiar rules were bent, stretched, or altogether rewritten? Among theorists, the debates grew intense. Some suggested dark matter might hold the key. If its particles clumped more quickly than predicted, they could have accelerated the collapse of gas clouds, creating early galactic scaffolding. Others speculated about the role of primordial black holes, seeds formed in the chaos after the Big Bang, whose gravity could have drawn matter together at extraordinary speed. More radical voices questioned whether cosmic expansion itself was mismeasured, whether the universe's age was not what humanity believed. Could the cosmos be older than assumed? Or was the flaw deeper still, embedded in the very equations that chart its expansion? As these questions multiplied, Webb revealed another layer of enigma, structure. Some of the earliest galaxies did not appear as chaotic smudges of light, but showed hints of organization, disks, spirals, alignments that spoke of order where only turbulence should have reigned. The young universe was supposed to be wild and unformed, like molten rock before it cools into stone. Instead, it displayed an unsettling maturity, as though cosmic time itself had accelerated, skipping formative steps. Astronomers, trained to expect gradual evolution, now confronted snapshots of a universe that seemed impatient. A cosmos eager to sculpt itself before the ink of creation was dry. And then there were the webs. Vast filaments of galaxies stretching across scales that should not yet exist. Observations hinted at early clustering, patterns echoing the great cosmic web that defines the present universe. Yet to see such alignment so soon was like finding a cathedral already raised at the dawn of civilization. These structures implied not only the rapid formation of matter, but its coordination across immense distances, as though the early universe carried within it a hidden blueprint, a predisposition toward order that current models could not explain. For astronomers, the revelations evoked awe, but also unease. Theories are meant to guide, to anchor the unknown within frameworks of logic. Yet the more Webb revealed, the less those frameworks seemed sufficient. Each galaxy was a paradox, each filament a contradiction, each heavy element a challenge to the neat chronology of the standard model. The very constants of physics, inflation, dark matter, dark energy, began to feel less like certainties and more like placeholders. Fragile scaffolds erected around mysteries that refused to yield, and in quiet moments, beyond the calculations and heated debates, a deeper reflection emerged. Perhaps the universe was not a puzzle designed to be solved, but a mirror designed to reflect the limits of comprehension. These galaxies, glowing across 13 billion years, were not simply ancient beacons, but reminders of humility. They whispered that reality is larger than imagination, that time itself may not flow in the linear sequence humanity perceives. Staring into Webb's images, humanity was confronted with the possibility that its most cherished theories were only stepping stones, temporary lights along a path that disappears into infinite darkness. In the silent depth of space, where the light of creation still lingers, the James Webb Space Telescope has pulled back the veil on a chapter of the universe that feels impossibly advanced, almost defiant. Among the earliest galaxies, blazing like lanterns on the threshold of time, astronomers have discovered something even more perplexing. Quasars, cosmic furnaces powered by black holes of staggering mass. These objects, usually billions of times the weight of the Sun, appear within the first billion years of cosmic history. By all accounts, they should not be there. For such giants to exist so soon would require black holes to grow at speeds far beyond the limits set by known physics. It is as though the universe, impatient with gradual evolution, leaped forward into extremes that theory had no room to hold. The presence of these ancient quasars touches the very fault line between the two great pillars of modern science, relativity and quantum mechanics. Einstein's equations describe how gravity sculpts space and time, how mass bends the geometry of the cosmos. Quantum mechanics rules the microscopic world, the realm of particles, uncertainty, and probability. For a century, these two frameworks have stood side by side, powerful yet irreconcilable. And at the heart of every black hole lies the singularity, a place where relativity breaks and quantum theory must take over, but no one knows how. Webb's discovery of early quasars forces science closer to this unresolved frontier. To explain them is to wrestle with the clash of the very laws that define reality. One speculative possibility lies in the notion of primordial black holes. Unlike the remnants of collapsed stars, these objects could have been born directly from the density fluctuations of the infant universe, forged in the raw turbulence that followed the Big Bang. If they existed, they might have served as gravitational seeds, drawing in matter and building galaxies around them like scaffolding in the void. In such a scenario, black holes are not the end of stellar life, but its beginning, architects of structure rather than tombstones of collapse. Webb's glimpses of enormous quasars, burning when the universe was still in its youth, breathe life into this once fringe idea, pushing it from speculation into urgent consideration. Dark matter, too, may hold a hidden hand in the story. In the present universe, its influence is inferred from the motion of galaxies, an invisible halo that outweighs normal matter 5-1. But what if dark matter behaved differently in those early epochs? If it interacted more strongly, clumped more efficiently, or even decayed in ways unseen today? It could have accelerated the collapse of gas, amplifying the birth of stars and feeding the rapid growth of black holes. Webb's revelations sharpen this possibility, suggesting that the unseen scaffolding of the cosmos may not be as timeless as once thought. Perhaps the properties of dark matter shifted with the age of the universe, leaving fingerprints that only the earliest galaxies still retain. Each of these interpretations carries with it profound consequences, not just for astronomy, but for the very map of knowledge itself. If black holes can emerge in the dawn of time, if dark matter shifts its nature across epochs, if the equations of relativity and quantum theory cannot hold together at the scales Webb now probes, then humanity stands at the threshold of new physics. The standard model of cosmology, long trusted as the guiding framework, begins to fray at its edges. Its constants no longer feel constant, its assumptions no longer safe. What was once seen as solid ground now trembles like sand beneath the tide of discovery. And so, in hushed tones, some scientists admit a truth that is both exhilarating and unsettling. The Webb telescope has carried humanity to the frontier of understanding, to the very edge of what can be explained. Beyond this edge lies a territory, unmapped, a domain where new laws may wait, where the universe itself whispers of principles not yet written into textbooks. For the first time in generations, astronomy finds itself not in refinement, but in revolution. The images from Webb do not merely display light from the past. They speak of the boundaries of knowledge, of horizons where human comprehension falters. To gaze upon those quasars, those infant galaxies burning with impossible maturity, is to sense the humbling reminder that the cosmos is not obliged to fit within the confines of human theory. It moves by its own logic, written in equations not yet known, in symmetries not yet grasped. The telescope has not only revealed the early universe, it has revealed the limits of human certainty, drawing a line where science ends and mystery begins, and yet it is in that mystery that meaning dwells. For at the edge of knowledge, imagination awakens. The universe, once thought mapped and measured, now appears as a living enigma, a vast and unfolding story that defies conclusion. Webb's discoveries remind humanity that to seek the truth is not merely to accumulate facts, but to stand in awe before the uncharted, to accept that wonder is not the absence of answers, but the beginning of them. The early quasars, blazing like cosmic beacons, do more than bend the limits of astrophysics. They bend the very notion of time itself. For if black holes of such enormity formed so quickly, then the pace of cosmic evolution must have been swifter, more condensed, almost accelerated beyond comprehension. The sequence humanity once trusted particles to atoms, atoms to stars, stars to galaxies, galaxies to black holes, now appears blurred, compressed into a timescale that challenges the very heartbeat of the universe. It is as if creation itself refused to crawl, choosing instead to run. In this revelation lies a haunting question. Is time in the early cosmos the same as the time that governs our lives today? Einstein showed that time is not universal, but elastic, stretching and shrinking under the pull of gravity and velocity. Perhaps in those infant centuries, when space was denser, hotter, and more tightly curved, the rhythm of time itself beat to a different measure. If so, then the rapid appearance of quasars may not be a violation of physics, but a glimpse into a domain where the flow of time was fundamentally different. Webb, with its mirrors tuned to ancient light, becomes not only a telescope, but a chronometer, revealing the malleability of time across cosmic eras. Dark matter's shadow deepens this puzzle. In the cosmic web, the vast lattice of filaments that thread galaxies together, dark matter acts as the unseen architect, pulling visible matter into its gravitational grip. Yet Webb has revealed structures too organized, to mature for so young a universe. Spirals and disks emerge when chaos should still reign. Did dark matter, in those epochs, guide matter with greater urgency, weaving galaxies faster than it does today? Some theorists whisper of self-interacting dark matter, particles that collide not only with gravity, but with one another, forming denser knots of structure. If this is true, then the universe humanity inhabits is but the late chapter of a story whose opening scenes were written with different rules entirely. Such possibilities stretch beyond the comfort of established theory. The standard model of cosmology, with its pillars of dark matter, dark energy, and inflation, has long served as the compass by which the cosmos is charted. Yet Webb's revelations point to fractures in its design. The cosmological constant, Einstein's symbol for dark energy, may not be constant at all, but shifting, evolving, a phantom force changing character over time. If so, then the accelerating expansion of the universe may be not a fixed truth, but a moving target, governed by laws that remain invisible at the edge of this mystery. Astronomers are forced to confront the fragility of their certainties. For decades, cosmology has been a tale of refinement, of adding decimals to known quantities, of measuring with ever-increasing precision. Now, precision itself unravels. The oldest galaxies shine too brightly, the earliest quasars grow too swiftly. The cosmic scaffolding organizes too soon. Each discovery is a reminder that the universe is under no obligation to remain comprehensible, that reality is free to exceed the frameworks of human thought, and yet it is precisely in this unraveling that progress is born. For when science meets its limits, when it finds itself pressed against the edge of the map, imagination becomes its greatest tool. Perhaps new physics will emerge, a theory uniting relativity and quantum mechanics, resolving the paradoxes of black holes and singularities. Perhaps dark matter will reveal itself not as a single particle, but as an entire family of unseen actors, each playing a role in the cosmic drama. Perhaps time itself will be redefined, not as a universal flow, but as a variable shifting across the vastness of spacetime. In the end, Webb's discoveries do not merely rewrite equations. They reawaken a truth humanity once held close, that the cosmos is not a solved puzzle, but a living mystery. Each photon captured from the edge of time is not an answer, but an invitation to wonder, to question, to step beyond the boundaries of what is known. The telescope's mirrors, cold and unblinking, reflect not only the infant universe, but the face of a species standing at the edge of understanding, staring into the abyss and daring to ask what lies beyond. For, in those quasars, in those impossible galaxies, humanity sees more than anomalies. It sees a mirror held up by the cosmos, a reflection of its own hunger to know, and the humbling reminder that the universe is vast enough to always stay one step ahead. Under the cold brilliance of Webb's mirrors, the universe has revealed its riddles with unsettling clarity. Yet even as anomalies gather, the instinct of science is not surrender, but adaptation. Cosmology, like the galaxies it seeks to understand, evolves under pressure. When the data bends against expectation, theory reshapes itself in response, striving to remain aligned with what the sky declares. And so, at the frontier where surprise meets reason, new models begin to emerge, each attempting to reconcile Webb's revelations with the grand story of the cosmos. For many, the first place to turn is inflation, that fleeting instant after the Big Bang when the universe is believed to have expanded faster than the speed of light, stretching quantum ripples into the seeds of galaxies. It is within this mysterious inflationary epoch that some now suspect the answers may lie. Perhaps inflation was not a single smooth burst, but a more chaotic process, uneven and fragmented, producing regions of the cosmos where matter clumped, earlier, denser, faster. In such a universe, galaxies might have assembled sooner than expected, their birth accelerated not by chance, but by the very blueprint of the primordial fabric. Others look closer to the stars themselves, rethinking the efficiency of cosmic alchemy. For decades, models assumed a measured pace of stellar ignition, clouds of hydrogen collapsing slowly, gravity wrestling with pressure, light dawning cautiously in the dark. But Webb's galaxies burn brighter than such caution allows. Could the first stars have formed with greater urgency, igniting more readily, perhaps with a higher fraction of their gas converted into luminous fire? If so, then the brilliance of these ancient galaxies may not be a violation of physics, but a testament to nature's speed in the crucible of creation. Mass estimations, too, fall under scrutiny. When Webb measures distant galaxies, it does so through light stretched and filtered by unimaginable distances. Astronomers must translate those faint glimmers into mass and structure, a process laced with uncertainty. Some suggest that these galaxies may not be as enormous as they appear, that their stellar populations might be smaller, their brightness enhanced by bursts of star formation, or even magnified by the cosmic lenses of intervening clusters. In this light, the so-called giants of the early cosmos may shrink into more manageable proportions, their mysteries softened by the margins of measurement. Dark matter, that unseen scaffold of the universe, is also summoned to the table of revision. Its invisible pull governs the architecture of galaxies, binding the cosmos in a silent grip. If dark matter behaved differently in the early universe, clumping with greater vigor, or interacting in ways yet unknown, then the accelerated growth of galactic structures might be explained. The role of this elusive matter, long treated as static and unchanging, could instead be dynamic, shifting in influence across the ages. At the heart of these discussions lies the timeline of reionization, that epoch when the first stars and galaxies bathed the cosmos in ultraviolet light, tearing apart the fog of neutral hydrogen that once veiled the universe. Standard models placed this era hundreds of millions of years after the Big Bang, a slow awakening from darkness. But Webb's galaxies suggest a far earlier dawn, light piercing the void sooner than predicted. If the timeline of must be rewritten, then the story of cosmic history itself shifts, compressing epochs, once thought separate, into a single, luminous surge. In all these efforts, one truth remains clear. Webb is not yet a contradiction, but a challenge. The telescope has not shattered the standard model of cosmology, but it has stretched it to its limits, demanding refinement, nuance, and humility. Like a sculptor reshaping clay under new light, science bends, not breaks, adapting to the contours of truth revealed by the stars. For the universe is not a static text, but a living manuscript, its words rearranged with every new observation, its meaning deepening with every photon captured. Yet the deeper these theories reach, the more they reflect a haunting reality, that knowledge itself is provisional, that certainty in science is never absolute. The cosmos does not yield its mysteries willingly. It reveals them only in fragments, leaving humanity to stitch together. A tapestry that is always incomplete, always subject to revision. Webb's discoveries are not the end of cosmology, but the latest reminder that the story of the universe remains. At its core, unfinished. The hum of the universe is rarely simple. Every attempt to refine its story opens new doors, revealing yet deeper chambers of complexity. And so, Chapter 8 does not end with a handful of quick answers, but with a labyrinth of theories, each carrying its own elegance, its own risks, its own fragile attempt to reconcile the heavens with human thought. Among the most debated revisions stands the idea of cosmic inflation reimagined. The original model, proposed in the 1980s, was designed to explain why the universe appears so uniform across vast scales, why its geometry is so nearly flat, and why matter clumped into galaxies at all. Inflation was the great equalizer, stretching space to incomprehensible proportions in a fraction of a second. But Webb's findings suggest that the aftermath of this event may not have been as smooth as once believed. If inflation had subtle irregularities, slight variations in speed, density, or duration across different regions, then pockets of the cosmos might have condensed into galaxies far faster than the overall timeline predicts. This patchwork inflation could be the hidden hand behind the anomalous galaxies Webb now observes. The universe, in this view, was not a uniform expansion, but a restless, uneven tide. Yet even if inflation planted the seeds, the growth of galaxies still demands an explanation. For that, many astronomers turn to star formation itself. Conventional models assumed a cautious efficiency. Only a small percentage of primordial gas would collapse into stars at any given time. But what if the first galaxies were not cautious, but prodigal? What if gravity's hand was stronger, cooling was more effective, and the physics of the early cosmos simply favored more aggressive starbirth? In that case, a galaxy could shine with astonishing brilliance, not because it contained more stars, but because it converted its gas into them with remarkable speed. Webb's observations of compact, intensely luminous systems lend weight to this possibility. Here, the cosmos appears less like a measured architect and more like an impatient artist, splashing light into the void with reckless haste. Even so, caution whispers through the field. The universe Webb sees is not handed to us in pristine clarity. It arrives filtered, stretched, and distorted by billions of years of travel. Light from the first galaxies is faint, redshifted, and easily misunderstood. Some scientists urge restraint, suggesting that perhaps the masses of these galaxies have been overestimated. The formulas that convert light into stellar mass carry uncertainties, especially when applied to stars that lived and died in conditions unlike anything we see today. Add to this the potential trickery of gravitational lensing, where massive foreground clusters bend and magnify light from background galaxies, and the apparent giants of the early universe might shrink into more modest sizes. If so, Webb's data would not demand a rewriting of physics, only a recalibration of perspective. And then there is the silent scaffold, dark matter. It has no glow, no shimmer, no voice, and yet its gravitational pull is the invisible architect of structure. Without it, galaxies would scatter like dust in the wind. In the early universe, dark matter's influence may have been even more pronounced, forming dense halos where gas could quickly pull and ignite into stars. If dark matter clumped with unusual efficiency in the first few 100 million years, then the rapid emergence of galaxies becomes less surprising. Some theorists even suggest that dark matter's properties might not be static, that it could interact more strongly under extreme conditions, only to grow more elusive as the cosmos aged. In that case, Webb may not be exposing flaws in the standard model, but glimpses of a richer, more dynamic dark sector still hidden from human equations. Reionization, too, must be revisited in this new light. For decades, cosmologists believed the universe spent its earliest epochs shrouded in darkness, a fog of neutral hydrogen absorbing the first photons. Only later, when galaxies and quasars emitted enough ultraviolet radiation, was this fog burned away, allowing light to travel freely across cosmic space. But Webb suggests this transformation began sooner, perhaps far sooner than expected. In the telescope's images, galaxies already blaze in an environment that should have remained veiled. If reionization occurred earlier, then the cosmic clock must be reset, compressing the timeline of events that define the dawn of structure. It is as though the first lights of creation were impatient, tearing open the curtains of night before physics had scheduled the show. Taken together, these revisions do not yet overthrow the standard model of cosmology. Instead, they bend its pillars, stretch its timelines, and test its assumptions. Webb's anomalies are not treated as fatal contradictions, but as stress tests, forcing scientists to refine their tools, their calculations, their narratives. The standard model still stands, but it trembles slightly in Webb's gaze, like an ancient monument weathered by a new storm. And yet, beneath these efforts runs a quieter current, a philosophical undertone. Every new theory, every recalibration, is a reminder of the fragility of human knowledge. What is believed today may be overturned tomorrow. What appears unshakable may prove to be provisional. The story of cosmology is not a tale of final answers, but of continuous approximation, an endless dance between certainty and doubt. The galaxies Webb has revealed are not just objects of study, they are mirrors, reflecting back the humility of a species that dares to chart infinity with imperfect tools. For scientists, to admit we do not yet know is not defeat. It is the essence of discovery. Each anomaly is an invitation, each contradiction a doorway. And in this way, Webb does not diminish humanity's quest for understanding. It deepens it, expanding the horizon of wonder. For in every faint light captured by its mirrors lies both a challenge to the present and a promise for the future, that the universe will always be larger, stranger, and more mysterious than any model can contain. In the long arc of human history, there has always been a frontier where knowledge blurs into mystery, and mystery blurs into imagination. Chapter 9 dwells in that liminal space, where speculation rises to meet the stubborn limits of fact, and where the James Webb Space Telescope, with its piercing gaze, has become less a scientific instrument and more a mirror, reflecting the vast spectrum of what might be possible, at the center of the debate lies the Big Bang itself, the pillar of modern cosmology, the singular event that gave rise to everything we see. For decades, its timeline has seemed unshakable, space expanding from an infinitesimal point, cooling into matter, condensing into stars, evolving into galaxies. Yet Webb's discoveries suggest galaxies shining in the darkness sooner than this. Timeline allows, as if the script of creation was rushed, lines spoken before the stage was ready. To some, this is not simply a miscalculation of models, but a crack in the foundation of the story itself. Could the Big Bang be less of a beginning than humanity has believed? Could it be one chapter in a cycle of many, the universe endlessly, expanding, collapsing, and rebirthing like a cosmic phoenix? The idea of a cyclic universe stretches back to ancient philosophy, but now finds new relevance. In some modern interpretations, the Big Bang was not the dawn of all existence, but the rebound of a previous cosmos that collapsed under its own weight. If true, Webb's galaxies may not be anomalies of speed, but relics, echoes of a universe that once was, faint embers from an older fire carried into this new expansion. To look at the earliest galaxies, then, may be to peer not only backward in time, but sideways, into the remnants of worlds erased. Even the meaning of redshift, one of astronomy's most sacred tools, is not beyond question. For nearly a century, cosmologists have treated the stretching of light as the signature of cosmic expansion. The farther a galaxy, the redder its glow. Yet a few voices, rare, often dismissed, but persistent, suggest alternatives. Could light itself grow weary across immense distances, losing energy in subtle ways not yet understood? If so, then, Webb's deep fields may not map an expanding cosmos at all, but something stranger, a universe whose fabric alters light in ways yet to be explained. Though mainstream science holds tightly to expansion as the likeliest truth, the very act of questioning reminds us that no tool, however trusted, is immune to doubt. Beyond these challenges lies the most audacious of speculations, that Webb's vision may have brushed against realities beyond our own. The multiverse hypothesis imagines our cosmos as but one bubble in an endless foam of universes, each with its own laws, constants, and histories. If two such bubbles touched, their boundaries colliding, the evidence might appear as anomalies in the cosmic microwave background, or as galaxies that should not exist where they are. Could some of Webb's puzzles, galaxies too large, too soon, be the scars of another universe brushing against ours? Such a possibility stretches the imagination to breaking point. Yet it remains within the realm of physics, whispered about in the corridors of theory. And then there is the idea that steps beyond physics into philosophy, the simulation hypothesis. If reality itself is an engineered construct, a coded framework written by an intelligence beyond comprehension, then Webb may be revealing not the deep physics of nature, but the limitations of the program. A galaxy appearing before it should, a black hole larger than allowed, a light that bends in ways no equation predicts. Could these be glitches in the fabric, errors in a system designed to feel seamless, but not infinite? While most scientists treat this as speculation untethered from testable evidence, it persists in the cultural imagination, a reminder that perhaps the strangeness of the universe is not just physical, but metaphysical. In all of these theories, cyclic time, tired light, multiverses, simulations, runs a deeper question. When evidence bends reality, do we bend with it? Do we cling to established frameworks, reshaping them to absorb anomalies, or do we allow ourselves to step into the abyss of possibility where models fracture and imagination must take the lead? Webb has not provided final answers. Instead, it has thrown open the doors of wonder wider than ever before. The universe revealed is not the tidy cosmos once envisioned, but a shifting labyrinth where beginnings blur into endings, where light itself may lie, where multiple realities may breathe alongside our own. To dwell here is to feel the smallness of human certainty, and yet the grandeur of human curiosity. For perhaps the greatest discovery of all is not that the universe is stranger than expected, but that it will always remain stranger than the mind can hold. If the universe is cyclic, then time itself is not a river with a single beginning, an end, but an ocean that rises and falls in endless tides. In this vision, every expansion carries the seeds of its own collapse, every collapse the promise of rebirth. Webb's galaxies, impossibly mature at cosmic dawn, could then be seen not as contradictions, but as inheritances. Like ancient ruins resurfacing after a flood, they may be the faint structures left over from a universe that perished before ours, carried forward in the rebound of existence. In this view, the cosmos is eternal but ever-changing. Galaxies, stars, and worlds are born, burn, and vanish, but the stage itself is never destroyed. Only the play is rewritten over and over. The thought carries both comfort and unease. Comfort in knowing that nothing is truly lost. Unease in realizing that even our own universe may one day give way, collapsing into silence, only to erupt again as if it had never been. Others turn their gaze to light itself. If the laws of the cosmos are written in photons, what if those laws evolve with time? The traditional reading of redshift tells us that space is stretching, carrying galaxies apart. But what if light, journeying across unimaginable gulfs, grows weary, its rhythms slowing, its color fading? This idea, dismissed by most, raises a haunting possibility that what we see is not the map of expansion, but the signature of fatigue. If true, Webb's farthest galaxies are not messengers from a violent birth, but storytellers from a more complex reality, one where even light itself ages. Taken together, these revisions do not yet overthrow the standard model of cosmology. Instead, they bend its pillars, stretch its timelines, and test its assumptions. Webb's anomalies are not treated as fatal contradictions but as stress tests, forcing scientists to refine their tools, their calculations, their narratives. The standard model still stands, but it trembles slightly in Webb's gaze, like an ancient monument weathered by a new storm. And yet, beneath these efforts runs a quieter current, a philosophical undertone. Every new theory, every recalibration, is a reminder of the fragility of human knowledge. What is believed today may be overturned tomorrow. What appears unshakable may prove to be provisional. The story of cosmology is not a tale of final answers, but of continuous approximation, an endless dance between certainty and doubt. The galaxies Webb has revealed are not just objects of study, they are mirrors, reflecting back the humility of a species that dares to chart infinity with imperfect tools. For scientists, to admit we do not yet know is not defeat. It is the essence of discovery. Each anomaly is an invitation, each contradiction a doorway. And in this way, Webb does not diminish humanity's quest for understanding. It deepens it, expanding the horizon of wonder. For in every faint light captured by its mirrors lies both a challenge to the present and a promise for the future, that the universe will always be larger, stranger, and more mysterious than any model can contain in the long arc of human history. There has always been a frontier where knowledge blurs into mystery, and mystery blurs into imagination. Chapter 9 dwells in that liminal space, where speculation rises to meet the stubborn limits of fact, and where the James Webb Space Telescope, with its piercing gaze, has become less a scientific instrument and more a mirror, reflecting the vast spectrum of what might be possible. At the center of the debate lies the Big Bang itself, the pillar of modern cosmology, the singular event that gave rise to everything we see. For decades, its timeline has seemed unshakable, space expanding from an infinitesimal point, cooling into matter, condensing into stars, evolving into galaxies. Yet Webb's discoveries suggest galaxies shining in the darkness sooner than this. Timeline allows, as if the script of creation was rushed, lines spoken before the stage was ready. To some, this is not simply a miscalculation of models, but a crack in the foundation of the story itself. Could the Big Bang be less of a beginning than humanity has believed? Could it be one chapter in a cycle of many, the universe endlessly, expanding, collapsing, and rebirthing like a cosmic phoenix? The idea of a cyclic universe stretches back to ancient philosophy, but now finds new relevance. In some modern interpretations, the Big Bang was not the dawn of all existence, but the rebound of a previous cosmos that collapsed under its own weight. If true, Webb's galaxies may not be anomalies of speed, but relics, echoes of a universe that once was, faint embers from an older fire carried into this new expansion. To look at the earliest galaxies, then, may be to peer not only backward in time, but sideways, into the remnants of worlds erased. Even the meaning of redshift, one of astronomy's most sacred tools, is not beyond question. For nearly a century, cosmologists have treated the stretching of light as the signature of cosmic expansion. The farther a galaxy, the redder its glow. Yet a few voices, rare, often dismissed, but persistent, suggest alternatives. Could light itself grow weary across immense distances, losing energy in subtle ways not yet understood? If so, then Webb's deep fields may not map an expanding cosmos at all, but something stranger, a universe whose fabric alters light in ways yet to be explained. Though mainstream science holds tightly to expansion as the likeliest truth, the very act of questioning reminds us that no tool, however trusted, is immune to doubt. Beyond these challenges lies the most audacious of speculations, that Webb's vision may have brushed against realities beyond our own. The multiverse hypothesis imagines our cosmos as but one bubble in an endless foam of universes, each with its own laws, constants, and histories. If two such bubbles touched, their boundaries colliding, the evidence might appear as anomalies in the cosmic microwave background, or as galaxies that should not exist where they are. Could some of Webb's puzzles, galaxies too large, too soon, be the scars of another universe brushing against ours? Such a possibility stretches the imagination to breaking point. Yet it remains within the realm of physics, whispered about in the corridors of theory. And then there is the idea that steps beyond physics into philosophy, the simulation hypothesis. If reality itself is an engineered construct, a coded framework written by an intelligence beyond comprehension, then Webb may be revealing not the deep physics of nature, but the limitations of the program. A galaxy appearing before it should, a black hole larger than allowed, a light that bends in ways no equation predicts. Could these be glitches in the fabric, errors in a system designed to feel seamless but not infinite? While most scientists treat this as speculation untethered from testable evidence, it persists in the cultural imagination, a reminder that perhaps the strangeness of the universe is not just physical, but metaphysical, in all of these theories. Cyclic time, tired, light, multiverses, simulations, runs a deeper question. When evidence bends reality, do we bend with it? Do we cling to established frameworks, reshaping them to absorb anomalies, or do we allow ourselves to step into the abyss of possibility where models fracture and imagination must take the lead? Webb has not provided final answers. Instead, it has thrown open the doors of wonder wider than ever before. The universe revealed is not the tidy cosmos once envisioned, but a shifting labyrinth where beginnings blur into endings, where light itself may lie, where multiple realities may breathe alongside our own. To dwell here is to feel the smallness of human certainty, and yet the grandeur of human curiosity. For perhaps the greatest discovery of all is not that the universe is stranger than expected, but that it will always remain stranger than the mind can hold. If the universe is cyclic, then time itself is not a river with a single beginning, an end, but an ocean that rises and falls in endless tides. In this vision, every expansion carries the seeds of its own collapse, every collapse the promise of rebirth. Webb's galaxies, impossibly mature at cosmic dawn, could then be seen not as contradictions, but as inheritances. Like ancient ruins resurfacing after a flood, they may be the faint structures left over from a universe that perished before ours, carried forward in the rebound of existence. In this view, the cosmos is eternal, but ever-changing. Galaxies, stars, and worlds are born, burn, and vanish. But the stage itself is never destroyed. Only the play is rewritten over and over. The thought carries both comfort and unease. Comfort in knowing that nothing is truly lost. Unease in realizing that even our own universe may one day give way, collapsing into silence, only to erupt again as if it had never been. Others turn their gaze to light itself. If the laws of the cosmos are written in photons, what if those laws evolve with time? The traditional reading of redshift tells us that space is stretching, carrying galaxies apart. But what if light, journeying across unimaginable gulfs, grows weary, its rhythm slowing, its color fading? This idea, dismissed by most, raises a haunting possibility that what we see is not the map of expansion, but the signature of fatigue. If true, Webb's farthest galaxies are not messengers from a violent birth, but storytellers from a more complex reality, one where even light itself ages. The Webb Observatory does more than reveal distant galaxies. It rewrites the boundaries of time itself. Every observation campaign it undertakes is carefully designed to peel back another layer of the universe's infancy. Scientists craft these programs like cartographers mapping an uncharted land, targeting galaxies less than 300 million years after the Big Bang, fragile structures, flickering in an age once thought too young to support them. Each deep field becomes a portal into an epoch where the first stars ignited hydrogen into light, seeding the darkness with fire. These campaigns are not simple snapshots, but prolonged exposures, weeks of patient staring into seemingly empty patches of sky. The faint photons that arrive carry stories across 13 billion years of silence. They are measured, calibrated, and compared against models that strain to keep pace. The numbers are then shared across the global community, where teams from Tokyo to Boston, from Paris to Cape Town, pull apart the data, checking, verifying, challenging. In this collaboration lies both the strength and humility of science. No discovery is real until it survives the fire of collective scrutiny. ALMA, high in the Atacama Desert, joins the search with its network of radio antennas, listening for the signature of cold molecular gas, the raw material from which galaxies are built. Where Webb sees the stars already burning, ALMA detects the invisible reservoirs that feed them. Keck and other ground-based observatories provide spectroscopy, dissecting starlight into its elemental fingerprints. Together, these instruments form a layered vision: the light of stars, the shadow of gas, the structure of dust, each contributing a piece to the cosmic puzzle. Even as Webb maps the faintest dawns, the Roman Space Telescope waits in the wings, with a field of view 200 times larger than Hubble's. Roman will not only zoom in on rare galaxies, but survey the universe in sweeping detail, revealing patterns invisible to a narrow eye. It will chart the scaffolding of dark matter, through the bending of light, hinting at whether the invisible hand that shaped the cosmos behaved differently in its earliest days. Farther in the future, the extremely large telescope promises a resolution that will dwarf even Webb's, its mirror. Spanning nearly 40 meters, will collect light with a power unimaginable in past generations. It may resolve the structures within those early galaxies, determining whether they are truly massive, or whether Webb's vision, though sharp, still deceives with distance. With each new machine, the frontier moves. The mystery does not fade. It sharpens, and behind the technology are people, thousands of scientists and engineers, bound not by a single flag, but by shared wonder. In dimly lit control rooms, they wait through long nights for signals to arrive. In conference halls, they debate fiercely, defending equations, questioning assumptions, pushing one another toward clarity. For every polished image released to the public, there are years of labor hidden beneath, misaligned instruments corrected, corrupted data reprocessed, models rebuilt from scratch. It is not only the stars that shine, it is the perseverance of those who refuse to stop asking. To live in this age is to feel the ground shifting beneath the pillars of cosmology. The Big Bang model, long held as the great narrative of origins, now faces questions too sharp to ignore. Some of Webb's galaxies are so massive, so chemically enriched, that they strain the limits of what 13 billion years could achieve. If the models are wrong, then the universe may be older, stranger, or more dynamic than humanity has yet imagined. And if the models hold, then unseen processes, dark matter shaping faster, star formation erupting more violently, must be at play. Either way, the horizon of truth has moved. Humanity now stands in a rare moment, when discovery is not a footnote to history, but a living experience. Generations past looked up with naked eyes and traced myths into constellations. Today, descendants of those same dreamers hold in their hands instruments that can glimpse the first galaxies themselves. It is the same longing, expressed in sharper detail, the urge to know where the story began. And as Webb continues its watch, as Roman prepares to join, as the ELT rises toward the desert sky, the question grows not smaller but larger. It is no longer just, how did the universe begin? It is also, what happens when the answers undo the story we thought we knew? The pursuit is unending. Humanity stretches its reach across billions of light years, not because the cosmos demands it, but because wonder does. And somewhere, in the silence between galaxies, lies the reflection of those who dared to ask. From the beginning of civilization, Humanity has lifted its gaze toward the night sky, searching for patterns in the stars and stories in the darkness. Ancient cultures drew constellations as maps of myth, convinced that the heavens revolved around the earth. It was a cosmos designed with humanity at its center, ordered and comforting. But each revolution in thought pulled that center farther away. Copernicus displaced the earth. Galileo revealed new worlds circling Jupiter. Newton unveiled invisible laws binding planets to the sun. And Einstein, with the sweep of relativity, bent space and time itself, showing that even reality's fabric could twist under the weight of mass and energy. The James Webb Space Telescope stands within this lineage, another tool, another eye, another leap. Yet what it reveals is not a neat extension of knowledge, but a challenge to the very order of the story. Just as earlier generations watched their certainties unravel, so too does this age stand in awe of discoveries that bend the timeline of creation itself. Webb's galaxies are not mere data points. They are reminders that the universe has never belonged to human expectation. In these moments, science is not only discovery but humility. It reminds the species that knowledge is not ownership but a fleeting glimpse through a keyhole. Each answer births a dozen new mysteries. Each revelation humbles, whispering that the human mind is both extraordinary and fragile, capable of spanning billions of years in thought, yet bound to a small planet orbiting an ordinary star. Still, the pursuit continues. The drive to understand the impossible is woven into human nature, as intrinsic as breath. The same hands that once lit fires in caves now launch mirrors the size of houses into space. The same minds that once drew myths into the sky now write equations that map the unseen. This hunger does not fade, for it is not born of utility but of wonder. Webb is more than a machine. It is a time machine, carrying vision to the very threshold of existence. It peers into epochs where stars were newborn, where galaxies bloomed in primordial darkness, where the universe itself was still unsteady in its expansion. Yet in doing so, it also carries humanity to the edge of comprehension, the point where language falters, where imagination strains, where the cosmos is no longer merely vast but unfathomable. To stand here is to recognize the paradox of being human, fragile creatures of dust daring to question eternity. It is to feel the weight of questions that may never be answered, and still to ask them. For perhaps the value of the pursuit lies not only in the answers, but in the act of reaching the courage to stretch thought beyond comfort, to surrender certainty in exchange for possibility. As the Webb telescope continues its silent watch, as photons older than Earth fall upon its mirrors, it becomes clear that humanity's place is not at the center of the cosmos, but within its story, a fleeting chapter in an ancient, ongoing tale. The questions asked today may be forgotten tomorrow, but the act of asking echoes forward, a testament to curiosity itself. The universe does not speak in words, yet it whispers through light. It reveals fragments, puzzles, contradictions. It tells secrets that should not exist, and still they arrive, etched across the sky in photons that outlived galaxies. And so the pursuit continues, patient, humble, relentless. The universe is whispering secrets it should not possess. And still we listen. To reflect upon the great arc of human history is to see a pattern woven into its fabric, a restless desire to step beyond the known. From the first sailors who dared to push past the horizon, to the philosophers who questioned the motions of the heavens, to the scientists who carved hidden laws into equations, Each generation has lived within a world shaped by wonder, and yet each has also stood upon the precipice of mystery, facing the uncomfortable truth that reality often defies expectation. The James Webb Space Telescope now extends this legacy, not merely as an instrument of astronomy, but as a mirror held up to human ambition. Its golden eyes collect light that has traveled across the abyss, stretching back to a time when no stars yet glowed in familiar constellations. In every faint smear of light lies a fragment of a forgotten epoch, a relic of an age when galaxies were assembling in ways no theory had quite predicted. These fragments confront modern science with questions as sharp as they are humbling.